so we are going to go through the mini quiz from 5.7. Our last mini quiz ever. Aww. All right, so going through this is a little tough one, so we'll kind of take it step by step. So we've got the graph of g is given up above, and then we have f of x is equal to 3x plus the integral from 0 to x of g of t dt. All right, so we want to find f of 7 and then f prime of 7. So for f of 7, we're going to just plug it right straight into that equation. So we've got f of 7 is going to equal 3 times your x, which is 7, plus the integral from 0 to your x, which is 7, of g of t dt. So it's going to be 21 plus the area under the curve from 0 to 7. All right, so we've got a semicircle that's below the x-axis, so that means it's going to be negative. 1/2 pi, my r is 3 squared, plus my area under that curve is 1 times height of 3. So that is f of 7. Do I need to simplify it? No, I do not. But if you want to, you can. It would be 24 minus 9 over 2 pi. Okay? You don't have to simplify it though. All right, now to find f prime of 7, well, the first thing I have to do is find f prime of x. So we'll find that first. So we'll do f prime of x is equal to, all right, derivative of 3x is 3, plus the derivative of the integral from 0 to x is going to be g of x. Okay, so that's the derivative. Now, if I want to find f prime of 7, I'm going to do f prime of 7 is going to equal 3 plus g of my x, which is 7. So it's going to equal 3 plus, let me just erase that little arrow, 3 plus g of 7, well, the graph of g at 7 is at 3. 3 plus 3, 6. All right, so that's it for part A. For part B, find the value of x. Do I care about the y value? Not really. Find the value of x in the closed interval from -4 to 3 at which f attains its maximum value. Oh, maximum CPs and EPs. All right, but actually this time, instead of my y value being my answer, they're asking for what is the x value that gives me the maximum y value. All right, so in this case, my EPs are -4 and 3. So I want to know, since this is asking about f, what is f of -4 and what is f of 3 equal to? Okay. And then my CPs are where the derivative equals 0 or does not exist. So where f prime equals 0 or does not exist. Now here's the challenge. It's got a 3 with my derivative right now. It's not just straight up g of x. So I can't be like, oh, slash, this is also f prime, because it's not. It's like slash, this is a graph of f prime minus 3. So it's a little bit tricky. So we're going to take f prime, my graph, and set it equals to 0. So where does 3 plus g of x equal 0? And that's where does g of x equal -3? G of x is equal to -3 at an x value of 3. But hey, that's an EP for this, so I don't need to worry about that one. Is there anywhere where 3 plus g of x is not going to exist? Is there anywhere where the graph doesn't exist from -4? No, it's a solid line all the way through. So it's going to exist everywhere. All right, let's get rid of all my scribble scrabble on the graph there. There we go. All right. So there's nowhere where it won't exist. So we actually have no CPs for this. Ooh, I didn't mean to erase the CPs. There are no CPs because the only CP is at x equals 3 because that's where my g of x is going to equal -3, but that's an EP. All right, so now we want to find f of -4. So we're going to do 3 times -4 plus the integral from 0 to -4 of g of t dt. And then we're going to do f of 3, which is 3 times 3 plus the integral from 0 to 3 of g of t dt. Okay, so this is going to equal -12. And then we do the area under the curve from 0 to -4. Shading backwards is negative. We switch the sign, so instead of it being a positive area, it's going to be a negative. 1/2 base times height. So the base is 4, the height is 2. So that's going to be -4, so that equals -16. And then 3 times 3 is 9 plus the area under the curve from 0 to 3. So that's 1/4, so it's below the x-axis, so -1/4 pi times 3 squared. Which one is bigger, -16 or 9 minus 9/4 pi? Well, this one is bigger. So it's x equals 3 because we only are asking for our x value this time. Okay, justify your answer. I check my CPs and EPs. That gave me the biggest. Okay, so I got to do a little bit of erasing because I wrote in where the next question is. Okay, so for the next question, let me switch colors. All right, so we got the limit as x approaches 0 from the left, with that little negative sign means from the left, of g prime. So this time we're talking about the derivative, aka what is the slope of the graph as x approaches 0. So on the left-hand side of 0, what's the slope as it approaches 0? Well, as it approaches 0, the slope of that curve is down 1/2. So this is going to equal down 1/2, -1/2. Now for this one, as my graph approaches 0 from the right, what is the slope of that curve becoming? So the slope is 0 here. Then it's going like this, this. When I get to here, it's going to be a vertical slope. What do we say when you have a vertical slope? The slope is undefined, aka does not exist. Okay? Alrighty, last one. We've got find the limit as x approaches -2. So the first thing we do with the limit is we plug in that x value and see what we got. Let me just change the color. So I'm dealing with a different color for a different letter. All right. So we plug in -2. So we've got f of -2 plus 7 over e of 3 times -2 plus 6 minus 1 equals whatever f of -2 is plus 7 over e to the -6 plus 6 is 0 minus 1. Uh-oh. Anything raised to the 0 power is 1, so that's going to be 1 minus 1. Uh-oh. I'm getting a 0 on the bottom. You getting all those feels right now? All right, up top, we've got f of -2. So f of -2. So I'm going to go up here and I'm going to plug -2 into my f function. So f of -2 is going to equal 3 times -2 plus the integral from 0 to -2 of g of t dt. Okay, so that's going to be -6 plus the area under the curve starting at 0 to -2, so I'm shading backwards. So I'm switching that sign. So negative 1/2 base times height. Base is 2, height is 1. So that's going to be -6 plus a -1. Uh-oh. Uh-oh. -7. -7 plus 7 is 0. I get 0 over 0. That is not good. We got to do something with that. All right. There's no chance in any way, shape, or form that I'm going to be factoring that and canceling. So now I have to rely on L'Hopital's rule. All right, which says I can also do the limit as x approaches -2, derivative of the top, f prime of x, over the derivative of the bottom, which is e to the 3x plus 6 times the derivative of that exponent, which is 3, and then the derivative of 1 is 0. And then I replug back in -2. I'm going to just change the color while I'm doing that one. Let's go bright green. So we've got f prime of -2 over 3 e to the 3 times -2 plus 6. So that's going to be 3 times e to the 0. So that's going to equal 3 times 1. So the denominator is going to be 3. And my numerator is going to be f prime of -2. Now remember, here's my equation for f prime. So if I do f prime of -2, that's going to be 3 plus g of my x value, which is -2. So it's going to be 3 plus, what's g of -2? G of -2 is 1. So 3 plus 1 is 4 up top. 4/3 is good. That is an answer. That is it. All right, Calcars went out with a toughie.